means. Okay, so oil production is problem 101 on page 242. Okay, so we're given the function p of t. We'll see in a moment what it represents. 2.69 t to the fourth minus 63.94 t to the third plus 459.895 t squared minus 688.692 t, and finally plus 24,150.217. P of t is the number of barrels in thousands. Fine. Produced t years after 2000. T equals 0 represents the year 2000. According to this model, in what year did worldwide oil production achieve an absolute maximum? What was the absolute maximum? So we're asked to find the maximum of P of t. What do we need to do? What do we need to find? We're given the function, and we are asked to find the absolute maximum. So what should we do? What do we need to determine? Anyone? Well, we have to find P prime. Without P prime, we cannot do anything. So 2.69 multiplied by 4, 1076 t to the third minus 63.94 multiplied by 3, 191.82 t squared plus 459.895 multiplied by 2, 919.79 t, and minus 688.692. So we determine the derivative, and it's a polynomial function. You will not have critical numbers coming from m prime, f prime, p prime being undefined. So I have to find p prime of t. I have to solve the equation p prime of t equals 0. And I have my special 20, 30-year-old calculator. I don't even know how old it is. And because I trust it much better than the newer one. And it's a polynomial degree 3. And the coefficients are 10.76, negative 191.82, 919.79, and the last one, negative 688.692. And I click on solve. And even the calculator needs some time. And it has new batteries, by the way. So I get t equals 9.68, t equals 7.24, and t equals 0.91. However, I have to say that this means nothing. I have no idea what this means. Who knows which of these gives a maximum? I have no idea. So 0, infinity, 0.91, 7.24, 9.68. If I don't study the sign of this polynomial, I will not know. And here's what I'm going to do next. I'm going to put the polynomial. Now I trust this calculator on this one. So I will put in that polynomial, the derivative, 10.76 t to the third power, and minus 191.82 t squared, and then plus 919.79t, and minus 688.692. And then second table, I will plug in 0, which I know it's going to be a negative number. I don't need to plug it in the calculator. I will plug in a number in between, let's say 5, and I will plug in a number in between, let's say 8. And I will plug in like 10. So I plug in 5, 8, and 10 to study the sign here. So 5, enter, 10, enter, 8, enter. For 5 is positive. For 8 is negative. And for 10 is positive. Very good. So next, because it's also asking us to determine those values of the function, I will also plug in the function. So in y2, I'll have 2.69. Whoever chose this problem lost the right to choose again. I'm kidding, of course. 63.94. t to the third. I'm absolutely kidding. It's a nice problem. Plus 459.895 t squared minus 688.692 x plus 24150.217. Okay, so I go back to second and table, and I have the values. Of course, at 0, we have 24150.217 for this, for 0.91. For 0.91, this is 23858. For 7.24. I determine all of them because I shouldn't, because I'm really asked to find the absolute maximum, right? So this is a minimum, because from negative to positive. This is definitely a maximum from positive to negative. This is a minimum, some minimum point from negative to positive. So this is the only one. So for 7.25 is 26,396. I'm going to find that too, since I'm here and I have the number. I have the calculator. It's all set up. 26,199. So it's clear that this gives the absolute maximum. 26,396. That's a critical number. Any questions? Any questions? Good. Hey, can we move on? Do we want to look at other problems, or we move on? Let's look at other situations with max min. They are in 2.5. We continue the same thing, finding max min of different functions in different situations, in real life situations. So now you tell me what you would like to look at. Maximizing profit, maximizing area, maximizing volume. If you have no preference, then I will choose. Okay, I would like to look at maximizing profit. Let's say 29 on page 255. Riverside Appliances is marketing a new refrigerator. It determines that in order to sell X refrigerators, the price per refrigerator must be, so the price is P equals 280 minus 0.4x. It also determines that the total cost is C of X, which is 5,000 plus 0.6 x squared. Find the total revenue. So the total revenue, part A, total revenue. Revenue of X is X multiplied by the price. Number of units multiplied by the price of the units sold. But the price is given to us in the form of 280 minus 0.4x. I will distribute negative 0.4x in descending order plus 280x. So this is the revenue. Part B, total revenue. Part B, any questions? Find the total profit. The total profit P of X is the revenue from the sale of X units minus the cost for producing those units. So I copy the revenue, which is this, negative 0.4x squared plus 280x, and I have to subtract the total cost. I have to subtract both. So minus 5,000 minus 0.6x squared. Negative 0.4 minus 0.6x squared, combining like terms, is negative x squared, and then plus 280x and minus 5,000. And that is the total profit. How many refrigerators must the company produce and sell in order to maximize profit? So in part C, we want to find maximum, what X should be for the maximum profit. Maximum profit, what should X be? I have to find the derivative. And I get negative 2x plus 280. I have to find the critical number by setting the derivative equal to 0. So negative 2x plus 280 equals 0. Negative 2x equals negative 280, or x equals 140 units. This is not sufficient. It could be a minimum. No, it could not, because it's a quadratic function with a negative leading coefficient, but I still have to show. And here's how I show it. That's all I need to do. Show 0 here. And since this is a linear function with a negative slope, it comes from positive and goes to negative. Or you plug in a number. And this is typical for a maximum. Up, down. In part D, what is the maximum profit? So basically, I will have to determine P of 140. That will be the maximum profit. I have the profit function. So P of X, again, is negative x squared plus 280x minus 5,000. So P of 140, I'm going to put it directly in the calculator. Careful with negative in front. 140 squared plus 280 times 140 and minus 5,000. And we get 14,600. Dollars. What price per refrigerator must be charged in order to maximize profit? So this is the maximum profit. So this was part D. And now in part E, we have where is my price? Right here. Okay. So the price is 280 minus 0.4 multiplied by 140. which is X for maximum profit. $280 minus 0.4, oops, 0.4 times 140. $224 per refrigerator per unit. Any questions on maximizing profit? Any questions?